Okay, Statistics for Decision Making, Lecture 3. We're going to talk about sampling today. Okay? Now, the idea is you're wanting to study a population. And usually, this population is too big to study every member of the population in order to find out about the population. So what we do is we choose a sample from the population, which is sort of a subset of the population. Okay? If there's 1 million people living in a particular city and you want to do a survey, you might survey 500 people. So the 1 million people in the city would be your population, and the 500 people that you survey would be your sample. Okay, now here's what's super important. A sample should have the same characteristics as the population it is representing. Otherwise, it's just no good. In the example I mentioned a second ago, where you sample 500 people from a city with 1 million residents, those 500 people are supposed to represent a microcosm of the whole city. So it's really important that those 500 people are chosen in a way that they accurately reflect the 1 million people in the whole city. Okay? All right, and the best way to do that is to do random sampling. And there's many ways to do random sampling. Okay, what does that mean? It means that your 500 people need to be chosen randomly. Okay? But there's several ways to do that. We're going to talk about a simple random sample, okay, and then we're going to cover stratified sample, and then cluster sample, and the fourth one is systematic sample. They all have their pros and cons, and I'll cover all 4 of those. Okay? So first let's do simple random sample. As the name would suggest, it's the simplest way to do a random sample. Okay? And the way to do that is to just pick people randomly. How would you pick people randomly? Okay. So, here's how you would do that. You would take the residents of the city. There's 1 million of them. And you would assign a number to each resident, 1 to 1 million. Okay? And then you would just use what's called a table of random numbers, or you can use on a computer what's called a random number generator. We'll go over how to use these things later when we actually start doing some samples. Okay, but the idea is you number everybody 1 to 1 million, and then you randomly generate 500 numbers between 1 and a million, and then the 500 people with those numbers, they're going to be your sample. Okay, that's how you do a simple random sample. Might sound a little bit unsimple just because there's a million people, but think about it. Let's do a smaller number. Let's say you have a class of 30 people and you're going to take a sample of 5. Then you just number people 1 to 30, and you randomly pick 5 numbers, and those 5 people are your sample. Or another way to do it is to take everybody's name and put it in a hat on a piece of paper, and then just draw 5 names out of the hat. That would be a simple random sample. Okay? So, as the name suggests, it's very simple. You just randomly pick individuals from the population. Okay? Very straightforward. But here's the key. I want to write down sort of the definition of a simple random sample. I just talked verbally about how you do it. Now I want to write down the definition. Okay? In a simple random sample, of, let's say, n individuals from a population, any possible combination of n individuals has an equal chance of being the combination that is chosen. Okay? All right. Let's move on and do a stratified sample. Okay, what is a stratified sample? Let's change to a new example. I'm not going to mention the city of 1 million people anymore. Let's say you're going to take a sample from the College of Business. And let's just say, for the sake of argument, that the College of Business let's just say that it has 1,000 students. Okay? And let's say it's broken up. I'm not saying this is necessarily the case, but let's just say that it's broken up into a finance department, and an accounting department, and a marketing department, And let's throw in one more. How about we'll do, how about Human Resources Department? Okay, and just for the sake of argument, let's pretend there's 500 students in the finance department and 100 students in the accounting department. And let's say 200 students in the marketing department and 200 students in the human resources department. Let's pretend that you're going to take a sample of, how about we'll say 100 students. And you want this sample to accurately reflect the proportionality of the departments in the college. Okay? Like, for instance, suppose you did a simple random sample. Then every single group of 100 has a equal chance of being chosen. So like, for instance, you might end up with 50 marketing students and 50 accounting students. But you might feel that that would not accurately reflect the College of Business because half of the college is finance. So if you end up with 50 accounting students and 50 marketing students, then you might feel that that is ignoring an entire half of the college. So you might say this, you might say to yourself, half of the college is in finance, so I would like for half of the sample to come from finance. 10% of the college is in accounting, so I would like 10% of my sample to come from accounting. And marketing and human resources each make up 20% of the college, so I would like them to make up 20% of my sample. I mean, that's a very realistic desire, right? So what you would do in that case, instead of doing a simple random sample and randomly choosing 100 students from the college, what you could do is you could choose, okay, 100 out of 1,000. How much is that? That's 1/10, correct? Okay, let me ask you this question. How much of the college is in the finance department? Half of the college, right? So, if my sample is 100 students, and I want it to reflect the correct proportion of finance, then how many finance students would I want? I would want to choose 50, right? How many accounting students would I want? Well, 1/10 of the college is accounting students, so I might want 1/10 of my sample to be accounting students. And what's 1/10 of 100? It's 10. You see the idea? You can probably guess the next two. How many marketing students would I want in the sample? Well, the marketing makes up 20% of the college, so I would like it to make up 20% of my sample, and 20% of 100 is 20, so I would choose 20 marketing students. And also, for the same reason, 20 human resources students. I'm not saying that a sample should be done this way. I'm saying this is one way of doing the sample. I think I need to move the screen over to the left. I fear that some of it was getting cut off. Okay? If your population is already broken up into separate categories and you want your sample to represent those categories in the same proportion, then this is a way of making that happen. And this is called stratified sampling. Okay? And the idea is you take the 1,000 students and you go ahead and separate them into the groups. In this case, there's 4 groups, and so you go ahead and separate them that way. And those groups would be called strata. And then you randomly choose individuals from each strata, and you do it proportionally, like I did here. The finance department is what portion of the college? It's half of the college. And if my sample is going to have 100 students, half of 100 is 50, so I randomly choose 50 finance students. The proportion of the college that is accounting is 1/10. So I do the same proportion in my sample. 1/10 of the sample I choose from accounting. 1/10 of 100 is 10, so I randomly choose 10 accounting students. And so on and so on. That's what's called choosing them proportionally. Okay? And that's called a stratified sample. And what does that do for you? That a simple random sample does not. The stratified sample preserves the proportionality of the different subgroups. I am not at all saying that simple random sampling versus stratified sampling, that one is better than the other. I'm not at all saying that, okay? I'm saying that they are two valid ways to get a random sample. Okay? All right, so let me write that down, the rules for stratified sample. So first, separate the population into groups called strata. Then randomly choose individuals from each strata in numbers that reflect the proportion of the population belonging to each strata. Okay, and that's stratified sample. Okay, cluster sample. How does that work? Okay, for this, you divide the population into groups called clusters. They do not have to be the same size as each other. Okay, and then randomly choose clusters. Okay, so how would that work with our College of Business that I mentioned earlier? Let's go back and look at that. And let's change the numbers this time. Suppose, for the sake of argument, suppose these 4 departments all had 200 students. Of course, that won't add up to 1,000, right? So we'll add another department in there. What would there be? How about we'll add one called management. Let's give them 200 students. Okay. So what you could do, if you wanted to do a sample of, let's just say, for the sake of argument this time, you wanted to do a sample of 400 people. Okay, then what you could do, and this would be a very easy way to do it, is you could just randomly choose 2 of the departments. And that would give you 400 individuals. Okay? Now I made the numbers here simpler so that they will, match up. What if you wanted to sample only 100 individuals? Then this wouldn't work the way I've written it, right? So what you could do if you only wanted to sample 100 individuals, this is just one possibility. I'm not saying that this is the way it would have to happen. It's just a possibility. You could take each department and split each department in half. Then you would have 10 groups of 100. And you could randomly choose one of those groups. Okay? That's called a cluster sample. All right, and then the last one we're going to do is called systematic sampling. Okay, systematic sampling is pretty simple. Okay, what you do is you pick a starting point, and then you choose every nth piece of data. Okay, what do I mean by that? Let's suppose we go back to our college example, College of Business here. The way we left it off, where there was 5 departments and each one had 200 students. Okay? And let's say here you wanted to do a sample of 100. 100 is what portion of 1,000? It's 1/10, right? Another way to say that is 100 goes into 1,000 10 times. So what you could do is you could list every student. You would have a list of 1,000 names. Pick a starting point anywhere in that list. Okay? And then just choose every 10th name. Of course, now, if you got to the end of the list and you didn't have 100 yet, then you would continue by just going back up to the top of the list. Because I said you pick a starting point, okay? And it's important to randomly pick the starting point. That's very important, okay? Don't pick the person whose name you like the best. You randomly pick a starting point. Well, that might be way down the list, okay? And so you're going to get to the end of the list if you're choosing every 10th person and your random starting point is way down the list, then you're going to get to the end of the list before you're done choosing 100 people. And so you would just go back up to the top of the list and continue. Okay? That's called a systematic sample. So let me write that down. You list out the population. Doesn't matter how you list it. It doesn't have to be alphabetical order or anything like that. You just list it out. Okay. And randomly pick a starting point. Okay. And then you have to pick every so often on the list, right? So how do you figure out how many people to skip each time? Okay, so you divide the population size by the desired sample size and I'll just put in parentheses. Let's say you get a number, I'll just call it K. The book says N here, but I believe I used N for something else earlier in this lecture, so I'm just going to say K. All right. So then from your random starting point, choose every kth person. Of course, you don't always, this doesn't always have to be people that we're studying, but I'm just using that as a general noun. Okay, so that's the 4 kind of sampling that are common. I know that's very small, don't worry, I'm not going to stop there. I just want to delete this part, and it's easier to do if it's small. Sorry, that didn't work. Now I feel like I'm wasting your time. Just a second here. Okay, there we go. Let's get that a little bigger. So that's your 4 kind of random sampling. Okay. All right, we're going to stop there for today. Have a good afternoon.